Chlorine bleaches any colored substance to colorless substance permanently because it can liberate nascent oxygen. So oxoacids of halogen, fluorine does not form oxoacids of halogen except for one uric acid, that is HOF. Interhalogen compounds are more reactive than the halogens except for fluorine. Hello my dear students, welcome back to the 11th session on the chapter P block elements. Last class we learnt about chemical properties of group 17 elements, as well as we learnt about chlorine and preparation of chlorine and some of the chemical properties. There are some more chemical properties which we will be learning today. Okay, so we'll see the first one, oxidizing action of chlorine. So what is the oxidizing action of chlorine? Chlorine oxidizes ferrous salt to ferric salt. You can see ferrous FeCl2, where iron is in +2 state, it is getting converted to +3 state. So this is oxidizing property. Also ferrous sulfate, you can see it is getting converted to ferric sulfate. So here ferrous salts are getting converted to ferric salts when it is treated with chlorine. Okay. Next, also it oxidizes sulfite to sulfate. I told you ferrous to ferric. Also sulfur dioxide to sulfuric acid and iodine to iodic acid. So what does it do? Ferrous to ferric it will oxidize. Not only that, it will convert sulfite Na2SO3 is sulfite to sulfate Na2SO4. Meanwhile, chlorine with water it will form HCl. Same way, sulfur dioxide gas with water and chlorine it will form sulfuric acid and HCl, and iodine, water and chlorine together will form iodic acid and HCl. So thus this is the oxidizing action. Next is about bleaching action. Chlorine bleaches any colored substance to colorless substance permanently because it can liberate nascent oxygen. You can see chlorine with water, it will form HCl and it will give away one single oxygen atom which is called as nascent oxygen. This will convert colored substance to colorless substance. So delicate articles should not be bleached using chlorine, okay, because it's very harsh on the article. This is about the bleaching action of chlorine. Next is reaction with hydrocarbons. If we have saturated hydrocarbon, for example, I'll take methane, CH4. When it is treated with chlorine in the presence of sunlight, there is substitution, that is one hydrogen will be removed and instead of that chlorine will come out, that is one chlorine atom, and you will get CH3Cl. So substitution reactions will happen if it is a saturated hydrocarbon. Now if it is an unsaturated hydrocarbon, just like ethene, you have carbon-carbon double bond. Okay, ethene I have taken up. So when this is treated with chlorine at room temperature, the double bond is broken and to this carbon atom one chlorine is added, to the another carbon atom one chlorine is added. So you will get 1,2 dichloroethane. So what is happening here? It is addition reaction what is happening. So if it is an saturated hydrocarbon, the reaction is substitution reaction, and if it is an unsaturated hydrocarbon, the reaction is addition reaction which will happen. So that's about the reaction of chlorine with hydrocarbons. Next we are going to study about the uses of chlorine. So if you see the uses of chlorine, it is used in manufacturing of several substances like bleaching powder, chloroform, HCl, carbon tetrachloride, DDT, chlorates, hypochlorites, etc. That's the first use. Manufacture of several types of substances. Next, in purification of drinking water, We know that sometimes water will have a stink of chlorine, isn't it? That is because chlorine was passed through water for purification purpose. Okay. Next, for bleaching of wood pulp in paper industries and rayon industries, and also bleaching cotton fabrics also it is used. It is used in extraction of gold and platinum. Also, it is used as a good oxidizing agent, germicide and disinfectant. That's why it is used purification of water. Also, it is used in preparation of poisonous gases like phosgene, tear gas and mustard gas. Okay. So, poisonous gases also contains chlorine atoms, just like tear gas, phosgene and the mustard gas. Okay. So, these are some of the uses of chlorine. Next, we are going to study about hydrochloric acid. HCl was first prepared by Glauber by treating sodium chloride, that is the common salt, with concentrated H2SO4. Davy was the one who proved that it is the gas which is produced in this reaction is made up of hydrogen and chlorine. So, what is the laboratory method of preparation? If we take NaCl, treat it with concentrated H2SO4 at 420 Kelvin, first it will form sodium hydrogen sulfate and HCl gas is liberated. Further, sodium hydrogen sulfate with NaCl at 823 Kelvin will form sodium sulfate as well as HCl gas is liberated. So, we will get HCl in both the reactions. Okay, this is the laboratory method of preparation of HCl. Next, we learn about the properties of HCl. First chemical property is acidic nature. Hydrogen chloride will dissociate in water to a large extent, that is, it's a strong acid, to give H plus ion and Cl minus ion, and its Ka value is 10 to the power 7. Okay, so it's a very strong acid because it can give away H plus ion. Next, reaction with ammonia. HCl with ammonia will form white fumes of ammonium chloride. What is it? Ammonia with HCl gives white fumes of NH4Cl, that is ammonium chloride. Next property is about aquaregia. Aquaregia is prepared using HCl and nitric acid in a certain proportion. What is the ratio? The mixture of concentrated HCl and concentrated HNO3 in 3:1. That is, you have concentrated HCl is to concentrated nitric acid in 3:1 ratio. This is called as aqua regia, which can dissolve even the noble metals. You can see here noble metal gold in the presence of the acid HCl, and nitrate ion is from nitric acid. So, you have H plus ion from the acids, both the acids, nitrate ion from nitric acid, Cl minus ion from HCl. It will dissolve to form AuCl4 minus, NO gas is liberated and H2O is formed. Similarly, platinum also in the presence of H plus ion, NO3 minus ion, Cl minus will form PtCl6 minus, nitric oxide and water. And these are forming complexes which will go into the solution. That is, the solid one, gold and platinum, if you put, you will get the salts which is dissolved in water. Thus, it can dissolve, what is it? Noble metals like gold and platinum. Okay, what is it? Aqua regia. Next one is about hydrochloric acid decomposes salts of weaker acids. That is, if you take sodium carbonate or sodium bicarbonate or sodium sulfide and treat it with HCl, okay, sodium carbonate will form NaCl, liberating carbon dioxide gas. Sodium bicarbonate also will form NaCl, liberating carbon dioxide gas. Sodium sulfide also will form NaCl to liberate sulfur dioxide gas. So, it will decompose the weaker salts of the acid to form or to liberate carbon dioxide or sulfur dioxide gas. So, this is the action of HCl. Next, it's about the uses of HCl. What are the uses of HCl? It is used in preparation of chlorine, chlorides and aquaregia. It is used as a laboratory reagent and it is used in the preparation of some of the medicines. Also, for extraction of glue from animal tissues and bones, HCl is used. Also, for cleaning iron sheets during tin plating and galvanizing, we use HCl. That is in galvanizing and electroplating methods to clean the iron sheets, we use HCl. So, these are some of the uses of hydrochloric acids. Next, we shall study about the oxo acids of halogens. When it comes to oxo acids of halogen, fluorine does not form oxo acids of halogen except for one which is known, which is called as fluoric acid, that is HOF. Okay, or it is also known as hypofluorous acid. There is only one oxo acid, but the rest of the halogens will form oxo acids of several types, but most of them cannot be isolated. That means they are stable in the solution form or in the aqueous solutions or in the form of their salts only. In the pure form, they cannot be isolated. So, we will see some of the oxo acids. First one is halic acid or hypohalous acid. You have hypofluorous acid. Fluorine will form only one type of acid. You can see rest all are blank because it will form only one type of oxo acid. Okay, but chlorine will form hypochlorous acid, hypobromous acid and hypoiodous acid. So, all the other three types of halogens will form this hypohalous acid. Next is halous acid or halic 3, that is oxidation status +3 in this. It is chlorous acid, only chlorine will give, whereas fluorine, bromine and iodine will not form halous acid or halic acid of +3 state, where the halogen is in +3 state. Next, we have halic acid in the oxidation state is +5, or we also call it as just halic acid. Here you can see we will get chloric acid, bromic acid and iodic acid. Next is about the perhalic acid, in which the halogen is in +7 state. We can see we have perchloric acid, perbromic acid and periodic acid. So, there are 3, or rather I can tell there are 4 types of oxo acids which are possible. Which is it? Hypohalous acid, then you have halous acid, halic acid and you have perhalic acid. So, there are 4 types of acids which are possible. Let's see the structure of each type only with chlorine. That is, first we will see hypochlorous acid, then chlorous acid, then chloric acid and perchloric acid. Now, observe the formula. You have HOCl, one oxygen is more, it becomes chlorous acid. Then you have one more oxygen more, it becomes chloric acid, and you have one more oxygen more, it becomes perchloric acid. So, every step the oxygen atom is the one which is going on increasing. So, we will see how to write the structure here. Okay. So, first if you see hypochlorous acid, for oxygen there are 2 bonds, that is one with hydrogen and one with chlorine, that is hypochlorous acid. Then we have chlorous acid, to which there is one more oxygen is added. So, that comes to the chlorine with a double bond O. Okay. So, that becomes chlorous acid. Next we have about chloric acid, in which one more oxygen is more. So, that also will put as double bond O. See, HOCl is as it is. As the oxygen is increasing, for the chlorine atom we are putting the double bond oxygen. Okay. So, now we have 2 double bonded oxygen, which is chloric acid, and when we have 3 double bonded oxygen to chlorine atom, it becomes perchloric acid. So, it's very easy to remember how to write the structure of the oxo acids of chlorine. Only about chlorine is there for you all in your syllabus. Okay. And this is important because they have asked in your previous paper. Fine. So, shall we move on? Next, we are learning about interhalogen compounds or interhalogens. Interhalogen compounds are formed when 2 halogens react with one another. They have a general formula of XX dash or AB, or I can write it as XX dash 3 or AB3 or XX dash 5 AB5 or XX-7 AB7, where X is the one halogen which is of larger size and X dash is the one which is of the smaller size. Also, X is the one which is more electropositive than X dash. You can see here X dash, what it will form. X is chlorine, smaller is fluorine, bromine with fluorine, bromine with chlorine, iodine with chlorine, iodine with bromine. So the X, what is there? The X atom is the atom which is larger in size and more electropositive. Correct? Next, if you see X dash, you have chlorine with fluorine, bromine with fluorine, iodine with chlorine and iodine with bromine. Here only the stable ones are there. Then you have X-5, chlorine with fluorine, bromine with fluorine and iodine with fluorine. That's all is there. Last X-7, I have only IF7, which is only iodine is forming with 7 fluorine atoms. Okay. So we'll see about the preparation of interhalogen compounds. There are several methods of preparation. Small change in the condition will give you the different interhalogen. So the direct combination of two different halogens, the product form depends on the specific conditions which is employed. For example, you can see equal volume of chlorine and fluorine if we have taken at 473 Kelvin, you will get 2ClF. If we have taken excess of chlorine with fluorine at 573, a little higher temperature, then ClF3 will be formed. If we take again I2 and Cl2 in equimolar, ICl will get. Okay. Similarly, iodine and chlorine, in that chlorine if you have taken in excess, will get ICl3. Okay. The one which is taken in excess will have more number in the molecule. Okay. Also, you can see bromine and fluorine diluted with water. Both are diluted with water. Then you will get BrF3. And bromine and fluorine where it is equimolar. But you can see that 5 fluorine atoms are there. Molecules are there, sorry. But it is equimolar. You will get BrF5. So, there are different methods of preparation in which only the conditions are changing or the ratio of the concentrations are changing to get different interhalogens. Okay. So next we will be learning about the properties. What are the properties of interhalogen compounds? Now, if you ask me, do we need to learn the entire table? Yes, for your competitives, it's very important. But when it comes to your board exams, it's not that very important because there is no question which is asked as of now from here. But for your competitives, yes, it's very important. Okay. The first one is XX dash. We have ClF, BrF, IF, ICl, IBr, in which ICl and IBr are solids. First one is colorless gas, pale brown gas, then it is spectroscopically detected gas, ruby red solid, that's alpha form, brown red solid, that's beta form, and a black solid. And we do not have the structure because it will be only 2 atoms are there, isn't it? Next we have XX-3. We have 1, 2, 3, 4 types. Okay. In that, first one is a gas, but from bromine onwards, bromine is a liquid, but iodine is a solid. Okay. And the structure, if you see, it is bent T shaped. Next we have XX-5. We have 3 types, that is IF5, BrF5 and ClF5. The first one is a solid, the other 2 are liquids, and all the structure is square pyramidal. Next we have XX-7, IF7, a colorless gas, that is structure is pentagonal bipyramidal. So that's about the properties of interhalogen compounds. If we see the physical properties, they all are covalent molecules and they are also diamagnetic in nature, and they have a physical property in between that of the halogens which they are made up of, and they have a melting point and a boiling point little higher than what is expected. So that's about the physical property of interhalogen compounds. Next is about the chemical property. First is reactivity. Interhalogen compounds are more reactive than the halogens except for fluorine. This is because, see, we have an AB bond in the interhalogen is weaker than AA bond or BB bond. For example, I have an interhalogen with ICl. Okay. So this bond is weaker than II bond and ClCl bond. Okay. That's why they are more reactive. Next is about the hydrolysis. The interhalogen compounds react with water to give halogen acids. If you see the halogen acids, the halogen is the one which is in smaller size, which goes with the hydrogen to form halogen acids. One more, it will give a oxo acid. Now the oxo acid, if it is an AB type of an interhalogen, it will give hypochlorous acid. AB3 type will give halous acid. AB5 type will give halic acid, and AB7 type will give perhalic acid. So this is about the hydrolysis of interhalogen compound. Next is uses. If you look into the uses, they are used as non-aqueous solvents and also fluorinating agents. Also, ClF3 and BrF3 are used in production of UF6 to enrich uranium-235. Okay, so that's about the uses of interhalogen compounds. Next session, we'll be learning about group 18 elements. So, I hope you have understood. Thank you, my dear children. Stay tuned, stay focused.